3, 2, 1, 0. All engine running. Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11. Tower clear.
Hey, this is Bill with the Apollo project. I want to demonstrate some of the functions that are programmed into the DSKY. This DSKY, of course, is the DSKY replica produced by S&T Geotronics. And this little marvel of engineering has done a really pretty good job of replicating the amazingly big marvel of engineering that was the Apollo guidance computer and display keyboard interface on the command module and lunar module. This is one of 2 units that I've gotten from S&T Geotronics that will be installed on the command module once it's completed. And this one normally would be battery powered. That's how all of them come from S&T Geotronics. And recently I've had the battery on the big back connected to it when I was at a couple of different events, one of which I attended with Mark Tessier of S&T Geotronics, which was the pre-launch gala for the Computer Museum of America. Mark had donated one of the DSKYs and one of his Enigmas to the Computer Museum. But also, given that the launch of the museum was on the anniversary of the Apollo moon landing, July 20th, they had an Apollo-themed display, and of course I wanted to get a photograph of me with the DSKY with the lunar lander. They had a full-scale replica of the LEM at the gala. But prior to the event, I polished off a lot of the code for many of the functions, but at the same time also put together a manual of the various functions. It's getting to the point where I'm forgetting which functions are in this thing because there's so many. So I've designed this manual. It's similar to the Apollo flight plan, and of course written in Futura fonts so that it resembles the original. And I have this organized in a number of different ways. I've got the verb list, a noun list, and the descriptions, and the prog list. I've also have it organized by the various functions categorized by their function class, such as the real-time clock operations, the IMU operations, some simulations, GPS operation, audio, various things like that. And we'll go through those here in just a little bit. As you know, the DSKY has a lot of really cool stuff built into it. It has the real-time clock, the RTC. It has the inertial monitor unit, the IMU, which measures linear acceleration, rotational acceleration, or should I say rotational position. It's more of a gyro. But oddly enough, the IMU happens to have a temperature sensor on it as well. This came as a surprise even to Mark, who's one of the group that designed it. Of course, it has the GPS in it. It has an MP3 player. Some of the other things that it has some additional lines out for plus minus 4 or 5 volts. It has some additional pins going out for future expansion, and I'm taking advantage of some of that, plus the extension of the lines for the neopixels. I've built an extension to that. This is just temporary, but it was for use when testing an extension that I built for the caution and warning lights for the command module. If you look at apolloexperience.com or the Apollo project on DeviantArt, you'll see some photographs and some descriptions about how I put those together. But it was through extending those lines out that I was able to control the caution and warning lights. And of course, as you see, I've got this now, instead of battery, I've got it powered, because eventually this will be powered by the either main bus A or main bus B of the command module itself once it's installed. But the code that I started with, I didn't start with the code that came with it. I started with Scott Pavlovic's code that I got from GitHub. His project on GitHub is available to anyone. And I've spoken with Scott, and he's okay with me taking what he started with and running with it to expand it some more. And he suggested making it a fork off of his, which eventually I will do. But what I'm going to do in the meantime is this version of the DSKY code I'm going to offer preloaded on Arduino Nano, along with a chip with the audio codes, the audio clips, in exchange, or not exchange, as a gift, a promotional for donations to the Apollo Education Experience Project GoFundMe page. And you'll see that link in the description, but I'll put that on the screen as well. Eventually, I'll have the code released in full. Of course, I'll have some additions made to it. In between now and when I add some additions, I've got to do some memory management, because right now I'm right at the edge of what this will hold and still function properly. It's designed to hold 30,720 bytes of program space, which really isn't a lot. But I don't have much left because I'm at 28,514 and definitely don't want to run right up next to it. So I've got to do some memory management to free up some space to add some additional functions. But the original DSKY came with about 4, I believe, functions and 3 audio clips. Now the total I've got up to just over 50 functions and 17 audio clips, 2 of which are system functions, with 15 really useful or interesting or fun audio clips. So I'm going to start by going through the basic functions first. And of course, because I'm forgetful and there's so many things on here, I'm going to go down the manual here. So to start off with, it's got the real-time clock, and that's what we're seeing displayed right here. As you know, the DSKY is accessed through verb, noun, program entries, and verb 16, noun 36 is just the time from the real-time clock. Right now it's 23 hours, 16 minutes, 54 seconds, and blah, 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 hundredths. The 16 is monitor, verb 06 is display, so if I went verb 06, it would just do a single capture. If I wanted to just capture a particular event and know exactly what time something happened. But then I can go back to the continuous monitor by going back to verb 16. Noun 37 is the date, year, month, day. And while I could do a capture, it's really not going to make a whole lot of difference except at midnight when the date will roll over. Oh, that's going to be very interesting. Noun 31 is something new that I've added. It is the mission, not the mission, it's the elapsed time since the DSKY was initialized. So it's been on for 17 minutes and 10 seconds. This will keep on running through all sorts of other functions. I will eventually show you a couple of reset functions. One is a soft reset. This will survive the soft reset, but the hard reset, the force restart, this will reset with that as well. Let's see, we have noun 34. That's not really going to display anything because 34 is a count up timer, and right now I haven't started it, so it didn't display anything. Noun 35 is a count down timer. 34 is count from event. 35 is count to event. And to access those, you would go to verb 25. So I'm on noun 35 right now. I can do verb 25. And it's going to ask me to set hours. Well, I don't want to do hours. let's do minutes. Let's increment that. And I could do seconds if I wanted to. And when I press enter, it's going to switch to 16:35, which is going to monitor the countdown. That's when it starts. It's 3 minutes, 2 minutes 59, and so forth and so on and so on. If I go back to noun 34, I mean, there's nothing there. So verb 25. Right now you can't set a start time for the count up. It's just going to start at 0. Eventually I will. That's why I have it start on 25. Verb 25 in the real DSKY would be to set register 1, R1, R2, and R3 together. That's why I have it start here. Eventually I will have them set, but again, I'm running out of memory. But you can just press enter now. It's going to switch to 16 and start the count up process. So it'll just keep on counting until either you stop it with reset, or if you do one of the hard reset, the verb 69, and I'll show you that in a little bit. Let's get this going again. So verb 25, and that's counting up again. Let's see. Noun 65 is mission elapsed time. This doesn't display anything at the moment because I have not yet run the launch simulation. Mission elapsed time, of course, is the time from liftoff. And since we haven't run the liftoff yet, it's not going to be showing anything. But it will eventually show the time from liftoff if you run the liftoff simulation. And I'll save that for the end because that's a 12-minute long simulation. But once that's run, I will show you this and some other interesting little functions that come off of that as well. If I wanted to do a noun 38, I'm moving ahead to the GPS functions. This is the time off of the GPS. And it's 3 hours, 21 minutes, 47 seconds. And the GPS is going to be UTC, a Universal Time Coordinated. So it's Greenwich Meridian Time. Or what used to be GMT, now it's UTC. So it's 4 hours ahead of, I'm in Eastern Time, so it's 4 hours ahead, so it's actually 3:22 in the morning. And if I did noun 39, that is the date from GPS, and you can see it's already rolled over to the 20th. The date on the real-time clock was the 19th. So it's showing August 20th. 19. You notice that it doesn't have the 20 since the the date is in Epoch 2000. So it just shows the last 2 digits of the year. I can copy this from the GPS into the real-time clock if I wanted to. So if I want, let's see, noun 38. Actually, let's go. I don't have to. I can do verb 26, enter noun 36, and then it shifts to 16:36. But now you see that the time has been set to match the GPS time. It's now 3:23 in the morning. Well, since I live in Eastern Time and not in London, I need to set that back. So I can go verb 25. Again, I get to set all 3 registers with verb 25. So I can back this back down to 23. I don't need to change that. I'll run this up a few seconds. I can only press this so fast. There we go. So now it's back to normal. I could do the same thing with 26:37. Copy the GPS date into the real-time clock date. Keep in mind it's well, actually, I've got it set so it doesn't. It adds the 2000 to it, so it will take the Epoch 2000 and convert it to regular year format. So it'll be fine. And similar, I can do verb 25, 37, and set the date. Let's see, noun 37. You notice that I can switch between them. I don't have to do verb 16 noun 37 or the verb-noun combination every time. If the verb matches, I can switch between the programs, but just by entering the noun. Conversely, if I already have the noun, I can select a corresponding verb that works with that noun just by entering the verb now. So if I wanted to set the date, I can do verb 25, and now it's asking month, day, year. And now it changes to something different. If I set the time with 25:36, it switches to 16:36, but if I set the date with 25:37, it switches to 16:19, which displays the day, month, hour, minute, month, day, hour, minute, and it also displays the temperature. This is coming off of the IMU I mentioned before. And it's displaying it in relatively real time. Updates twice a second, I believe. But I can influence that. Right now it's showing 74. It's oscillating between 74 and 75 degrees Fahrenheit internal temperature. But if I were to say rub my finger on something to friction build up the temperature, I can touch the IMU and we can watch the temperature rocket up. And if I let go of the IMU, it starts cooling off, the temperature drops. And speaking of the IMU, let's move over to the IMU functions. You can display 17, and this, my manual is backwards. I have this on GPS. I need to do IMU. IMU operations are past the GPS. I'm ahead of myself here. Okay. These are actually the linear acceleration values. So I've got these swapped in the manual, but noun 17 is linear. So if I were to go sideways, you'd see the numbers increase. If I went to noun 18, I'm showing rotational position, and this one of course is the largest because it's horizontal. Once I move this vertical, it approaches 0, and if I keep on going, it'll go to plus. I can rotate sideways, and the top one zeroes out and the middle one increases. And just like before, I can do verb 06 and get a single capture of that. If I wanted a capture of the linear acceleration, I can do noun 17. And I've got one capture of that. And I skipped GPS. There's not a whole lot to GPS. We've already mentioned being able to view and copy the date and time off of GPS. But the main function of GPS, let's go verb 16 again, noun 43, displays the latitude and longitude. Prog 25, you see it, the upper displays will flash briefly to indicate that that the DSKY changes these on its own. It doesn't do it if you're changing them yourself, but if it changes them, it'll flash to bring your attention to it. So Prog 25, well, wait for it to come back. Prog 25, it's displaying the latitude. 34 plus is north. 26 shows the longitude. So negative 84 is going to be west. Let's switch back here. It alternates every 5 seconds. And it's degrees, minutes, seconds, and hundredths of seconds. Degrees, minutes, seconds, hundredths of seconds. And we'll just keep on doing that. There is no corresponding verb 06 for this because of it alternating. It has to stay in monitor mode. But those are some GPS functions. Let's jump ahead to some of the miscellaneous functions. You already know about verb 35, which is the lamp test, which will test everything. The difference is this. This is something that happens on the real DSKY. It'll flash those briefly before returning to your previously selected function. The soft reset verb 36, excuse me, let's clear that out. Verb 36 is the soft reset. So it clears that out. If you go to verb 16, noun 31, which is the system uptime, it still shows that. If I go to noun 34, it still has my count from event running, so it's 9 minutes, 10 seconds from event. And I believe I've probably overshot my 35, which is a countdown. Yeah, it's counted down to 0 at this point. But if I were to enter verb 69, whoops, I have a bounce problem there, verb 69, which is the force restart, and now if I did verb 16, noun 31, the system uptime is only 17 seconds, and noun 34 is going to, it's not going to show anything. Because it hasn't been initialized yet, it doesn't actually change the registers, it just does a capture. So if I could do noun 35, zero those out, noun 34, it's nothing. So verb 25, I can start the count up timer again. Verb 37, enter noun 00, starts program 0. Verb 37 is execute major mode. Major mode 00 is idle mode, or POO or poo. So it's just basically nothing. But I can return to verb 16, noun 36, and I can get my timer back. So now we can get to the audio functions. Similar to the original setup for the OpenDisky, program 62 plays the JFK We Choose to Go to the Moon clip. It plays a short version. The long version can be selected separately. P69, Eagle has landed clip. P70, the Apollo 13, Houston, we have a problem clip. I've added a couple of others. So if I did program 61, whoops, program 61, I get to hear JFK say,
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the earth.
And that's the short version. We'll be able to hear the long version later. I've also we have program 68, which is Apollo 8's Christmas greeting, as they came around and saw the sunrise over the lunar horizon.
We are now approaching lunar sunrise, and for all the people back on Earth, the crew of Apollo 8 has a message that we would like to send to you. In the beginning, God created the heaven and the earth, and the earth was without form and void, and darkness was upon the face of the deep. And the Spirit of God moved upon the face of the waters. And God said, let there be light. And there was light. And God saw the light, that it was good. And God divided the light from the darkness.
And similar to the others, I've got a longer version that you can play individually. And to play clips individually, I have a number of different functions. The clip playback is verb 16, noun 98. I won't run that just right now. But to select it, in the same way that verb 25 selects all three registers, verb 21 selects a single register, which would be R1. Verb 22 selects a single register, and that's R2, the second one. Register 1 for now 98 is the clip number. I mentioned there are 17 clips. The first 2 are system clips. The first clip is nothing but a little piece of silence. And the reason for that is because the MP3 player, as people who own these already know, is an indexed type of player. It'll just play the next one in sequence. The software has to keep up with which one it believes it's on, and will forward it to the one that it thinks it needs to play. But when it first starts to play it, the clip number 1, it plays about a quarter of a second of clip number 1, and so that's why you hear that "wheat" right before it plays whatever else it's going to play. And so by having that little clip of silence there, you don't hear that anymore. It's a nice clean start because there's silence before the playback of your selected clip. The second one is an alarm, and I will show you that. You'll be able to hear that when I show you one of these simulations. So the playable clips start at clip number 3 and run through clip 17. So by default, it's going to be in clip number 3. So if I went to verb 16, enter noun 98, it will be ready to play clip 3 when I press enter. So press enter.
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the earth.
And that's clip 3. If I want to change the clip number, I can go to verb 21, and it's going to wait for me to press a number, so I can just run up through and select a given clip. If I select clip number 12, press enter, it shifts to 1698, and I can press enter again, and it will play my selected clip.
I was strolling on the moon one day in a very, very month of December. May, that's right. May is the year of the month. When much to my surprise.
This is from Apollo 17. This is the astronauts being a little bit on the silly side.
Sorry about that, guys, but today may be December.
And Mission Control trying to jump in with the silliness as well.
Okay, Bob, the battery covers are closed. I'm going to go mode switch 1. I guess I'll just wave goodbye. You look pretty clean, so I won't touch you. Okay, thank you.
Being silly. So, as some owners of the OpenDisky also know, because the audio playback is indexed, it can get off. Sometimes it's just because the software forgets where it's at. Maybe you did a soft reset of the software without turning the machine off. In that case, just turning the disky off and back on will fix it. But if for some reason the clip numbers on the chip are also off, then it's always going to play back the wrong one because it has the wrong index. With this software, you can set an index adjustment factor in register 2. So instead of playing clip 12, right now it plays clip 12 plus the adjustment factor of 0, so it still plays clip 12. So I can do verb 22, and it's going to allow me to enter an adjustment factor here. So if I did an adjustment factor of 2, it's going to play clip 14, which ought to be the long version of a JFK clip. So let's enter that, and let's play back.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one that we're willing to accept, one we are unwilling to postpone, and one we intend to win, and the others too.
And so you can get your Disky back on track by entering the adjustment number if you happen to be off. But if you get this software preloaded on the Nano, and with the chip that I send, I will have already tested everything to make sure it works correctly. So you shouldn't have to worry about the adjustment factor. So I'm going to fix that and put it back to 0. And I'm just going to play that again. So, yeah, there it comes. So I don't want to hear that again, so I'm going to turn this off and back on. And you'll see the power-up sequence is going to be similar to the restart sequence. I've made that change as well. Excuse me. And that's audio function. Now let's get on to the simulations. Of course, the two big simulations are the launch of the Apollo 11 Saturn V and the Apollo 11 landing. Even though this is going to be mounted in the command module, I still have the lunar module simulator loaded, just because of its interest and fun. But I've got a couple of other simulations, one of which, if you've seen the movie Apollo 13, you know that they shut down the guidance computer to save power in the command module. There really is a shutdown function. They didn't show the entire function. They showed a little bit of it. But to get to that function, you would do verb 37 noun 06. Noun 06 is a major mode, which is the place the AGC in standby. So you can do verb 37 enter noun 06, and this is going to go into verb 50 noun 25, which is please perform. 5025 is the DSKY asking the astronaut to do something. That the particular something it's asking will be in register 1. In this case it'll be number 62. So we'll do that. So it's asking us to do function 62, which is to go into standby. And just like the real one, once you get here, there's no exit. You have to go into standby mode whether you want to or not. And so to go into standby mode, you hold program down until you see the standby light come on. And if you've seen Apollo 13, you watched Kevin Bacon do this. He held the Pro key down until the light went off. Light went on and the display went off. To restart it, you would just do the same thing. You'd press the Pro key again. We don't see pressing the Pro key in the movie, but what we do see is when the DSKY starts up after being shut down, it has a sequence of lights that come on and then a display that pops up on the right hand side. So I've simulated that. So if I press Pro, you get to see the sequence of lights come on, which will match the movie. And after it restarts, it will give us a display which also matches what we see, what Ken Mattingly, Gary Sinise, saw on his display after he brought up his AGC. And of course he's asked, "Is your computer up, Ken?" And he says, "Yes, it is." I thought, "I think we got it, buddy." So that's what he sees there. The simulation that I mentioned that has the alarm sounds, that would be verb 16 noun 87, which is, it's just going to display, oh, there you go, one popped up all of a sudden. It displays the IMU rotational position, the gyro information, and it randomly throws in a 1202 with the alarm. And that's pretty much taken directly from Scott Pav's code. That was such an interesting little thing, I just kept it pretty much as is. Press clear, you clear that out, and go back to normal. It didn't really simulate anything, it's just an interesting little function to include. Let's see, now 36, go back to time. Some of the other functions that I've simulated are, again, the mission elapsed time, which is 1635. I haven't run the launch simulation yet, so it's going to be at 0. Noun 32, Time to perigee, same thing. We haven't launched, so there is no orbit to go to. Now on 44, this is orbital parameters, apocenter, pericenter, and freefall, which is time until you impact the Earth. And of course, we haven't launched, so none of that's showing right now. So those things will be available. There's another verb 82, which is only available during the launch simulation itself. That brings up the 1644 orbital parameters and allows you to return back to the launch parameters. I'll demonstrate that last, because the launch simulation, again, is about 12 minutes long. But the next thing I'm going to show is the lunar landing simulation. It's just a playback. It's something that Scott Pav had in his code, but what he had was just random numbers. I believe they were, I don't know if they were actually random numbers or if they were coming off of the IMU. But anyway, they were not accurate to the landing itself. So I've recoded the landing simulation. I still use his same audio, which starts at about, I think it's an altitude of 3,500 feet to landing, about 15 seconds after landing. But what I've done, I have taken the actual flight profile, the altitude and the vertical velocity, as well as the time from the deorbit burn that was executed to put them on the landing approach to the moon. So you'll see in 1668, which is the display mode, the time from the deorbit burn, the vertical speed in feet per second. It'll be feet and then in tenths. It won't have a decimal place, but the last digit is tenths of feet per second. And then the bottom number is going to be the actual altitude in feet from the lunar surface. It starts off in program 64. When it gets to the attitude hold mode, it will switch to 65. And then on final approach, it'll switch to program 66. And if you listen carefully to the audio, you'll hear one of the mission control personnel say P66. And so now the lunar landing simulation, which is verb 16, noun 68. Starting in program 64.
Eagle, Houston, you're go for landing, over.
Roger, understand. Go for landing. 3,000 feet.
Copy.
1201.
1201. Roger, 1201 alarm.
Same time, we're go, flight.
Okay, we're go. We're go. Same tide. We're go.
Flight settle right on. Real 2,000 feet. 2,000 feet. Into the ag, 47 degrees.
Roger.
47
How's the
degrees.
margin looking, Bob? It looks okay. We've got 4.5. Roger. Eagle looking great. You're go.
Altitude update in the eggs. Looks good.
Roger. Roger, 1202, we copy it. How you doing, Control?
35 degrees.
We look good here, fine. Raj, how about you,
35
Tom?
degrees.
Go. Guys, you
750,
happy?
go.
Fight
Coming
off.
down
Go.
to 23. 700 feet, 21 down. 33 degrees.
21 down, that's the
100
vertical
feet down
speed.
at 19.
And he
540 feet down at 30.
reports
Down at
the
15.
altitude. Change to program 65.
Okay, at hold. I think we better be quiet.
That's the at hold,
100 feet
attitude
down
hold.
at 9.
Okay, the only call-outs from now on will be fuel.
Skate forward. 350 feet down at 4.
P66.
30 lift and a half down. Your egg done horizontal velocity. 300 feet down, 3.5. 47 forward. Put up. And 1.5 down.
I'm a little off here, but that's okay.
At the shadow up there. 50 down at 2.5.
So we're back to synchronized.
Okay, Bob, I'll be standing by for your
Altitude,
call-out
velocity
shortly.
light. 3.5 down. 220 feet. 13 forward. 11 forward, coming down nicely, 200 feet. 4.5 down. 5.5 down. 660, 6.5 down. 5.5 down. 9 forward.
Low level. Low level.
Good. 20 feet. 100 feet, 3.5 down. 9 forward. 5%. 185. 75 feet. Starts looking good. Down a half.
Roger.
6 forward.
60 seconds.
60 seconds. Lights on. 6. Down 2.5. Forward. Forward. Good. 40 feet down 2.5. Picking up some dust. 30 feet, 2.5 down. Straight shadow.
Stand by for 30.
4 forward. 4 forward. Drift into the right a little.
30
Down
seconds.
a half. 30 seconds. Forward. Just. Good. Hey. Contact light. Okay, engine stop. ACA at a descent. Nose control both auto. Descent engine command override off. Engine arm off. 413 is in.
We've had shutdown.
Here it comes.
We copy you down, Eagle.
Okay, everybody, T1. Stand by for T1.
Tranquility Base here. The Eagle has landed. Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot.
And once the simulation is complete, it goes back to 1636. And now the final simulation is the Apollo 11 Saturn V launch simulation and the corresponding functions that you can use during and after the launch. It's going to be Major Mode 1, so that would be Verb 37 Noun 01. It'll start about 35 seconds before launch, T-minus 35, and run to about 12 minutes, which would be after they give the go for orbital. Orbital insertion, which would be Saturn, the stage 4 S4B cutoff at 11 plus 42. And then there's a little bit of chatter as they report the orbital status and bring back the go for on orbit. So the Apollo 11 launch simulation, Verb 37, Noun 01, and it starts in Noun 01, which really would be a number of minutes before launch, which the program would go from 01 to 02 when it would have its the FDAI has been set to the correct azimuth for launch. What I've done instead was have it switch from 01 to 02 at about T-minus 15 when guidance goes internal. But apart from that, it's pretty accurate. It will switch to various display modes as it would correctly do during the launch. So here we go.
That's one free press. Roger.
Okay, it's 1636. It's in the countdown mode right now.
MC
And it'll be switching to probe 02 shortly. There you go.
GRR, Roger, GRR.
10, 9, 8, 7, 6, 5, 4, ignition. Liftoff.
Roger, clock. Clock start flight, Roger.
Okay, Roger clock. That means the mission elapsed timer has started. So the software has actually started the mission elapsed timer that you can view later on inside the DSKY. So what we're seeing right now, we're seeing absolute speed in feet per second. we're seeing vertical speed in feet per second, and altitude.
Roger, sir. Roll is complete and the pitch is programmed. Roger, roll, roger, pitch.
The altitude in nautical miles.
For 1 Bravo. Mark, 1 Bravo.
Now we're at 2.1 nautical miles, 890 feet per second absolute, and 724 feet per second vertical. The functions you can look at now, you could do noun 32, and this displays the time to perigee, which is going to be 55 minutes and about 20 seconds until perigee. It's sort of meaningless at the moment, but it's something you can view. You can also view the orbital parameters, verb 82, and these are basically meaningless at the moment. It indicates that the apocenter is 10.3 miles, but the pericenter is about 2,100 miles below the surface of the Earth, which is not very good. But you also have a free fall time of about 21 seconds before you would impact the Earth if you shut off all thrust at the moment. So it's not displaying anything very useful at the moment.
Stand by for mode 1 Charlie. Mark, mode 1 Charlie. Staging, booster, go. Fired up, go. Guidance, go. Good for staging, Captain. Apollo 11, this is Houston. You are go for staging.
And so if you go to either one of those displays, like verb 82, you can return to the launch parameters by pressing program.
We confirm inboard, better. Confirm inboard. Roger.
And same with noun 32. That's 53 minutes and 56 seconds to perigee. So return to the launch parameters. 9,000 feet per second.
And ignition. Cut off ignition.
Okay, we're on second stage.
Thrusters go all engines. Looks good.
We're about as fast vertically as we're gonna get. We're starting to level off. As you start leveling off, the vertical speed decreases, but the horizontal speed is going to increase more. Altitude's 50 miles, nautical miles.
Roger, we confirm. Roger.
Skirt SEP, the ring between the Saturn first stage and Saturn second stage has dropped away.
Houston, be advised the visual is go today. This is Houston, roger that. Let me know when it converges, guys. Yeah, they finally gave me a window to look at. That's good, flight converge.
Yeah, he's sort of being humorous about it, but
your guidance is converged, you're looking good. Kevin, stable at 5 knots, Mike. Kevin.
he's being a little bit humorous about the window, but he's basically reporting that his BPC, the boost protective cover, has cleared after the tower jet. I mean, now his windows are clear, he can see out. We're at 10,500 feet per second absolute. We're down to 1,800 feet per second vertical. We're at 75.5 nautical miles altitude. "52 minutes to perigee." These are shaping up a little bit. Pericenter is, or epicenter is at 81 miles. Pericenter is still 1,300 miles below the surface. That's still not good. Free fall, if thrust cut off immediately, we would have about 4 minutes to impact.
How you look, Booster? Booster flight. Still flight? Oh, look okay. That's a firm flight. Looking good. Keep down flight. How you? Looking good flight. Good at 5 minutes, Captain. 11 Houston, you are go at 5 minutes. Roger, 11 go.
One thing you'll notice that this is verb 06. It should be.
Stand by to add 4V to COI capability. Okay.
S4B to COI capability. Roger.
S4B to COI. If they lost the second stage, they could still make a contingency orbit, COI, contingency orbital insertion, using just the Saturn 4B.
You all are coming through beautifully too.
But anyway, Verb 06 would normally be a single display, but during the boost phase, it's being updated, but it's being updated once every 2 seconds as opposed to twice a second that Verb 16 would display.
Roger 11, your go from the ground at 6 minutes. Flight booster, go.
But Verb 6 Noun 62 is what would be displayed during launch, during the Prog 11. They're reporting engine cutoff times.
Apollo 11, this is Houston. Level sense arm at 8+17. Outboard cutoff at 9+11.
Okay, epicenter is 94.9 miles. We're less than 1,000 miles below surface on the pericenter, but we're 11 minutes to impact if we lost thrust at the moment.
Flight, how are you? Go flight. Guidance. Go flight. GNC. Go flight. Decom. Go flight. Good at 7 minutes. 11 is good. 7 minutes. 11, this is Houston. Roger, your go from the ground at 7 minutes. Level sense arm at 8+17. Outboard cutoff at 9+11. Roger.
Notice the vertical speed has dropped quite a bit. Definitely flying more horizontal in relationship to the surface of the Earth than vertical. This will actually get to a negative number because they'll reach a peak and actually start dropping back toward the Earth just ever so gradually.
Go ahead, flight. Here we are, there's the line ringing. I see that. I don't get a buzz on it. I'll check it. Inboard cutoff. Roger, we confirm. Confirming the board now. Roger. Guys, flight, how are you? We're go flight. GMC. Go flight. Decom. Go flight. And booster. Go flight. Shorted up, press flight. Flight, we're right on the ground track. Roger. Flight pilot, good agreement.
20,000 feet per second absolute speed. Should be staging shortly.
Apollo 11 Houston, you're go at 8 minutes.
Actually, we have about a minute before staging. Altitude is 100 miles.
Shift down here too. Let's just go flight. Roger. Looks like a nice day for it. Thunderstorms downrange is about all. Okay, boosted flight, how are you for staging? We're going for staging flight. Guidance, how are you? Go. Go for staging, Captain. 11, this is Houston. You are go for staging. Over. Stand by for mode 4 capability. Stand by for mode 4 capability. Mark. Mark, mode 4 capability. Cut off. Roger. Stages and ignition. Ignition confirmed. Thrusters go. Ignition confirmed. Thrusters go. 11.
Okay, third stage is active. How's our orbit looking? Better. Epicenter of 102.6. Pericenter is still beneath the surface, but it's almost there. 30 minutes to free fall impact.
Booster flight, are you? We're go flight. We're good at 10 minutes, Captain. Apollo 11, this is Houston. At 10 minutes, you are go. And Roger, let's go. Flight final all sorts of degree, we're go. Roger, guys, you got a predicted cutoff. Roger, flight is settled down at 11 plus 4-2. satisfied with that one? Go with it. 11 plus 4, 2. Okay. Apollo 11, this is Houston. Predicted cutoff at 11 plus 4, 2. Over. 1142, Rich. Booster flight, are you? We're go flight. UNC. We're go flight. Easttown. Go flight. Guidance, are you? Go flight. Sergeant. We're go flight.
$25,000 feet per second, absolute.
Apollo 11, this is Houston. You are go at 11.
And we are actually now very slightly dropping back toward the Earth.
Right up for flight, how you? Looking good. Flight little noise on raw. All sources agree. We're go. Okay, just standing by for your confirm. Right to that flight. Flight route clear. East Coast bound. Roger. Cut off. We are showing 101.4 by 103.6. Roger, shut down, and we copy 101.4 by 103.6. Stand by for you, Fido.
103.6, that's the perigee altitude of the orbit.
Flight Fido, we are go. Confirmed go. Apollo 11, this is Houston. You are confirmed go for orbit. Flight guidance, unit is go.
And on conclusion of the simulation, just like the lunar landing, it returns to verge 16, noun 36, showing the time. And you can do noun 44, display the orbital parameters. We had the apogee, epicenter at 103.6, pericenter 101.9. 5959, that's the number we were looking for. That means we are on orbit and we are in free fall. The coast around the Earth, we do not have to worry about impacting the Earth at that point. We can go to noun 32, and it's 43 minutes 18 seconds to perigee. And this actually is based on the actual orbital period of Apollo 11. It calculates the apogee at cutoff of the S4B, and then divides the period by 2 to get the time to perigee. And if you leave this running for a while, once you get to perigee and it reaches 0, it restarts with the orbital period. So time to perigee would then again be 1 full orbit. We have, of course, the mission elapsed time, 65, which is T plus 14 plus 5 after liftoff. So that is an additional little bit of simulation that I've thrown into this set of programming. And that's a little demonstration of the programming that I have done for this particular implementation of the DSKY. This is the software version that I will provide preloaded on the Arduino Nano that would be given as a gift, a bonus, in thanks for the donations to the Apollo Education Experience project made through GoFundMe. Again, the link to the GoFundMe page is in the description, and also it should be on the screen at the moment. I have not yet determined the bonus numbers, but by the time this video is posted, I will have those numbers updated on the GoFundMe page. I'll have one amount that if you donate that amount, you'll get a copy of the Nano programmed with this version of the code, as well as a micro SD card with the audio clips already programmed onto it, tested to make sure that they play, and you don't have to worry about the index, but the index would be there. And there'll be a second amount that if you donate that amount, you get not only the nano and the chip, but you will also get a copy, a printed copy of the OpenDisky command reference in your choice of cover colors. This one, of course, is blue, and you can choose either blue or gray or yellow or tan or green. Those are the choices that you could have. And of course, this is complete. It'll have all of the functions that would be available, the instructions on how to use them, a quick ref of the various nouns and verbs and programs that are available. And all that would be sent to you as thanks for donating to the Apollo project. And so that's the end of this demonstration video. I appreciate you watching. I hope that it was interesting and informative. And if you have an OpenDisky and would like these, donate to the project and I'll get those out to you. If you don't already have an OpenDisky, then you need to get one from S&T Geotronics. Their link is also in the description. And if you are handy with electronics, you can get the kit. Or you can, if you are not handy with electronics, you can get the fully assembled and tested version. And you can then donate to the project and get a copy of the updated code and the Arduino that already installed on it, and the chip that you can replace into the MP3 player, and you'll be able to enjoy all of these functions that I've set up in this Disky. And again, thank you for watching, and we'll see you later.